Hi everyone, welcome back. So GFG problem of the day today is sorted subsequence of size 3. So we are given an array ARR. We need to find any three elements in it such that ARRI is less than ARRJ is less than ARRK and I is less than J is less than K. So we have to find an increasing subsequence. If we have a subsequence and we return that, then the output will be 1. If we return an empty array list, then the output will be 0 from the code. And if our subsequence is not correct, the output shown will be -1 by the code. So this is what we have to do. Now moving to how to do this, we have to find a subsequence. Means we have to find three elements in increasing order without changing the order. So first approach that comes to our mind, the basic brute force approach is for each element we will put a loop on the array. Now for each array element we will put a loop towards the left side to find the smaller element, and next loop towards the right side to find the greater element. And if we have found a smaller element and a greater element, that index and element can be the subsequence. But what will be the time complexity for this be? For each index we are traversing the left side and the right side, means whole array. So an elements array means n elements for each element n times. So for n elements n times, so n square approach, so the solution is n square, but our array size is 10 to the power 5, means we will get TLE, time limit exceeded. Or the basic more easier brute force approach is 3 for loops for I, then j, then k, and checking if I is less than j is less than k. Then this approach will be NQ, that too will be TLE. So how to do this in ON with ON space? So for that, what we can think is, what approach we can think is, for any element, what we were doing is we were finding out a left minimum and a right maximum, right? This was only we were doing using the loop. We were putting a loop towards the left side and finding the left minimum, and we were putting a loop towards the right side to find the right maximum. Now what if for each element we pre-compute this? We pre-compute the left minimums and right maximums, store it somewhere, and afterwards when we are finding the answer for any index, we will just use the pre-computed values. So this shall optimize our solution to ON time. So this is what we will be doing today. Now I hope you have got the idea what approaches we thought of and how we optimize those approaches. Now we shall see how we will implement that approach of left minimum and right maximum, storing the left minimums and right maximums. This approach is mostly used in competitive programming to solve various questions because it optimizes our time. So we have created a left minimum array, means moving from the left side we will be finding the minimum element for each index. And similarly we have made a right maximum array, moving from the right side towards left and finding maximum for each index. So for left minimum, the 0th index value will be the array 0 value itself. Now we will put a loop from 1 to array.length and keep on finding the minimum of previous minimum or the current element ARRI, and that we will store at the left min index I. So this loop will store the left minimums for each array index. If that element itself is the minimum, then that will be stored, otherwise the previous minimum. Similarly we will be doing for rmax at the last value. We will be having the last element because we are moving from right to left. So we have put a loop for array.length -2 to till 0. Now we want to find the maximum of the right element or the current element. We will find the max and store it at rmax I. So this will give us the right maximum. If the current element is the maximum, that will be stored, otherwise the right maximum means the maximum element at the right hand side. So we have got both our arrays. We have got the left minimum array and the right maximum arrays. Now what we have to do, we just have to put a loop on our array and check if left minimum is not equal to ARRI, means we have a previous minimum, and if the right maximum is not equal to ARRI, means we have a right maximum, means a maximum number on the right hand side. So if these two conditions are fulfilled, we just have to store the left minimum, then array, current element, and the right maximum. If we have got a subsequence, we do not need to check for furthermore. There may be many subsequences. We do not need to check them. We can just break the loop and return our array list answer. So this was the optimization of the approach we thought of n square. We have converted n square approach to ON approach by using these pre-computed left minimum and right maximum arrays. So I hope you guys would have got the idea. Thanks for watching the video. Have fun. Bye.